looked at a lizard sunbathing on a rock in the middle of the day, maybe even in the desert, and wondered why doesn't that lizard get sunburned? If I were, as a fair-skinned person, to lay on that rock for 30 minutes, I would be completely red from head to toe. And yet here, this lizard sits completely unbothered by the sun. So, having noticed this, I really wanted to know, why is it that lizards don't get sunburned? And surprisingly enough, the answer took me to all places: genetics. So, what exactly causes a sunburn is the first question we have to answer. And that's where the structure of DNA becomes important. And we've been talking about DNA a good bit in my biology class. And one of the main things that is important to know if you want a basic understanding of DNA is the molecular structure, and specifically that DNA only works and replication only works because there are base pairs that very specifically bind to other base pairs. So in DNA, there are four different kinds of nucleotides. There's adenine, thymine, guanine, and cytosine. And no matter what, adenine should always pair up with thymine, and guanine should always pair up with cytosine. That means if this molecule were unzipped and half of it remained, you could replicate the other half, because if you know half of the code, then you know the other half of the code. So what sunburn has to do with this is when UV light hits a skin cell, it actually damages the DNA within that cell. Specifically what it does is it breaks these bonds here in the middle between these base pairs, between the adenine and the thymine and the guanine and the cytosine. And in the case of thymine, that is particularly bad, because what happens here, you see in the second picture, is when those bonds are broken and everything is just kind of left there being damaged, the thymine pieces of the puzzle are going to join up together. So that's called a thymine dimer, and those are bad. Anytime that DNA gets completely out of order, that's not a good thing. So when these dimers form, the cell realizes, hey, my DNA is completely messed up. This is bad. And cells have a special kind of programming. When their DNA gets messed up, they start to program their own death to occur. This is called apoptosis. And the reason for that is bad genetic information can lead to cancer, most specifically. So cells that start replicating incorrectly, which is primarily what cancer is. And so any cell that thinks, oh, my DNA is messed up, I need to stop replicating, I need to make sure I die. Well, that's what happens to these cells who are damaged by UV. So you've got the whole surface of your skin being covered in cells that are damaged and programming their own death. So your body realizes that all of this destruction is happening, and it starts flooding the area with blood and bringing sort of protective mechanisms and inflammation, basically trying to begin the healing process really, really quickly. So after a while, I mean, you're going to turn bright red from the inflammation and the blood flow, you're going to hurt, and eventually, after a few days, those dead skin cells are going to slough off and peel, which is why you have that sort of peeling that happens if you get a bad enough sunburn. Some of these cells, though, don't program their own death like they're supposed to. And if they don't, then they might, over a period of time, result in cancerous cells, and that's kind of what causes skin cancers. Sunscreen, however, can provide sort of a barrier to the UV light. It's literally a physical barrier for most sunscreens. They contain elements like zinc that prevent the UV photon from actually entering and getting to the DNA of the cell. And that's generally how sunscreen works. Okay, so what does this have to do with lizards? I'm getting back around to this. Well, lizards, among other animals, have this enzyme in their skin cells called phytolase. So phytolase is an enzyme. And what happens with phytolase is when visible light hits it, as in what would be happening if the UV were hitting your skin cells, the electrons in the enzyme are going to get really excited, and they're going to specifically inject themselves and form this little water bubble in the spot where the thymine bonds will be broken. So they're basically going to serve like these little molecular placeholders. And that's going to prevent those thymines from joining together and forming that dimer that is so damaging. And it's going to hold that place until the cell's normal DNA repair mechanisms can come through and repair it. So essentially, animals who have this particular type of enzyme, this phytolase, don't get sunburned because the damage never really occurs. It gets kind of held off until the cell can repair itself. So animals that have this are lizards, like we've said before, turtles, fish, birds, frogs, and even non-animal things like plants. The only animals that don't have phytolase are mammals, like us. So the question isn't so much why don't lizards get sunburned, it's why do we get sunburned? Why don't we have phytolase? And there aren't really clear answers to that. There's some evidence that mammals used to have the ability, used to have phytolase as an enzyme and have lost it over time. Some people theorized it's because mammals in the early stages of their evolution were primarily nocturnal. And so they didn't need it, and so there was no selective pressure in natural selection for them to keep it. So anyway, that's why lizards don't get sunburned, and that's why we do. And if you have any more questions about that, you can find me here or you can catch me at school.